Chapter 7, Problem 1. Let's tackle this question. The Hamilton Company is a member of a perfectly competitive industry. So again, we're discussing perfectly competitive market. Like all members of this industry, total cost function is given as TC, monthly total cost in dollars, equal to 25,000 plus 150Q plus 3Q square, where Q is the firm's monthly output. Question A. If the industry is in long-run equilibrium, what is the price of the Hamilton Company's product? Question B. What is the firm's monthly output? So this question asks you to utilize your understanding about long-run equilibrium. What happens in the long-run equilibrium? Profit in the long-run equilibrium should be zero. Otherwise, there will be entry or exit of firms to the market or from the market, right? So let's tackle question A and B step by step. Question A. To find the price of Hamilton Company's product in the long-run equilibrium, you recall that since Hamilton is a representative firm, you can determine the competitive long-run equilibrium price by finding Hamilton's minimum average total cost. So the company utilized all the technological advantage by adjusting the variable factors in the long run, but after all this effort, still the minimum average total cost is equal to the price, so that the company's total profit in the long-run equilibrium is equal to zero. So you're supposed to find, question A, average total cost and the minimum value of that. So we are given the total cost, which is given as 25,000 plus 150Q plus 3Q square, and by dividing this total cost by Q, you can find out average total cost function as 25,000 divided by Q plus 15 plus 3Q. And you want to find out, so this long-run average total cost function will be looking like this one, right? U shape. And then you want to find out the minimal point of output. So something like here, right? Q bar. That's the output where it achieves minimum of long-run average total cost. So to find out the minimum value of this function, we have to use delta operation or basic calculus. So for example, this function, especially the first term, it can be rewritten as 25,000. 1 over Q is the case where the power is minus 1, right? Q to the power minus 1 plus 15 and plus 3Q. So if you want to apply delta operation to find out, to average total cost, to find out where it reached the minimum, where the slope is 0, right? So this is the slope. Where the slope becomes 0, you want to find the delta operation expression from the right-hand side of the equality before. So 25,000 that is multiplied constant is maintained there. And Q power minus 1, remember, power is multiplied in the front. And then you subtract 1 from the given power, so become minus 1, which is minus 2. And then 15 is constant, so there's no change from 15. 3 multiply Q. If you apply delta Q to 3Q, you have 3. So that's it. So it say that 25,000 minus, right? And Q power minus 2 is same as 1 over Q square equal 3 plus equal 0. So this can be moved to the other side, right? So I can rewrite this equation as this. Therefore, we can say Q square is nothing but 25,000 divided by 3. Therefore, Q equal square root 25,000 divided by 3, right? So that is about, if you use a calculator, 91.287, which is about 91 output. So that's the part of question answer A. So with this one, you can replug this Q equal 91 to average total cost. So once you do it, well, there are lots of things going on. Maybe we remove this portion. Let's say you find out Q where minimum of average total cost occur is 91 approximately, and plug in this to average total cost. So then average total cost where Q equal 91 will be 25,000 divided by 91 plus 150 plus 3 multiply 91 square, which is about 697.7. So that's the answer. So that will be the price in the long run equilibrium. Question B, what is firm's monthly output? Well, we already found the Q equal 91 when you're trying to find answer for question A. So good for you, you found the two answers at the same time. Thanks for watching.